I'll be presenting some very preliminary results from my PhD work, and I'm supervised by some amazing professors from UFS, Pretoria, and Eswatini. A big thank you to the APC team and to my recent ASM sponsorship. So, as a quick introduction to ecosystem services, this is defined as the regulating, supporting, and provisioning services we get from the environment and from biodiversity, and bats are a great example of this. Bats provide us with a range of ecosystem services such as pollination, they're great seed dispersal agents, and they can be used as bioindicator species, but for this talk I'll just be focusing on their potential pest control services of insect pests. A big thank you to Dr. Anna Bastian, who introduced the horseshoe bats to you yesterday. So there'll also be a few references to the Rhinolophus bats throughout this talk. So we know we need more sustainable agriculture. It's one of the major threats to biodiversity around the world, but it could also be a positive for bats if it's providing food and alternative roosting. So this field and new discipline has been termed agroecosystems, and elsewhere in the world, bats are known to consume economically important crop pests anywhere from $3 to over $50 billion a year. They're providing a pest control services to farmers and to us. But this hasn't really been established in South Africa yet in terms of deciduous fruits such as apples. And this is also an area of South Africa where very limited bat research has been done. So as a quick background for context, in apple farming, this is the summer growing season, but the late harvest cultivars are heavily infested by pests, and it's a relatively small crop in South Africa with only, well, it's growing, but you're looking at 25,000 hectares in the whole country, and what's great for me is a lot of these farms have a great insect monitoring protocols and database. So we all know where we are in South Africa, but I am talking about the central part of South Africa in the Free State province, which borders the Kingdom of Lesotho. And the pin drops represent the 6 apple farms that I work on, and the colors represent the same landowners. So I'm working on 6 apple farms, but I luckily only have to deal with 3 farmers, and the control sites aren't mentioned here. But please note that the 2 blue farms, Lasdorp and Fariso, are closer to the Willetty-Drakensberg Mountains than some of the others. So just in terms of methods, briefly, I've done so far 3 sampling sessions, so spring last year, summer this year, and very stupidly before the conference decided to go out again in winter. So in July, and I'm using the SM4 minis from Bioacoustics. So on each farm, I deploy 3 detectors in the same 3 places each time. So that's in the middle of the orchard, mid-orchard, it's the edge of the orchard, and the closest water source, which is always, unfortunately, an artificial water source. After a minimum of 3 sampling nights, I then move the detectors to the next farm. And then in terms of analysis, I'm using Kaleidoscope Pro and Kaleidoscope Lite for downloading, conversion, and then converting it to the much smaller zero crossing files to using analog. And this is just to look at species composition, relative activity levels, and what we have lying around. So I manually verified everything, labeled everything, went through it, and then I designed species-specific filters based on reference calls that we have from literature, but also based on our own release calls of the bats we've managed to catch, and then scanned everything with these filters and tried to automate the process a little bit, and then obviously manually had to check it again. So for the bat people, I'm defining one zero crossing file as a bat pass. So some preliminary results. I've recorded over 60,000 bat passes so far, and we're looking at plus minus 11 insect-eating bat species. I'm lucky that there's no fruit bats that occur in this area, so I don't need to worry about that human-wildlife conflict aspect yet. But what I need to just admit is that this data hasn't been corrected for yet. So some of the farms is anywhere between 3 and 6 recording nights per farm. That's because we had some SD card failures, some hard drives stolen, and just logistics in general, what happens when you do field work. And I won't be talking about foraging groups and the apple localities, but the edge clutter species had much higher species diversity and activity than the aerial foragers, and of course our clutter foraging yields, such as the rhinolophus bats, were a lot lower in occurrence, presence, and diversity. Although those water sources were artificial, they were quite a hub of bat activity, and then interestingly enough, the edge of the apple orchards have a lot higher bat diversity and activity compared to the middle of the orchards, which are relatively very, very quiet. So these are just some photos of the species we've detected so far acoustically, I must add. So some, like as I said, some very preliminary results on season. This is just mean bat diversity with standard error bars, and the spring indicated in pink across the farms, interestingly enough, had higher bat species diversity than what I would have expected summer to be higher. Of course, this pattern isn't consistent across the different farms, and winter, as most of us will know, much lower bat and obviously insect diversity. So if we focus then on bat activity of just the number of calls, then some more like clear patterns start to emerge that the 3 farms on your far right, Heritage, Lustdorf, and Starklet, have much higher bat activity in spring and summer compared to my other 3 farms, which were much lower. I haven't run the stats yet, so I can't use the word significance, but a lot of you hopefully have been hearing a very high-pitched squeaking at night around here, and that's one of our little free-tailed bats, so there's a high chance it's this cute little guy, the Egyptian free-tailed bat. So Tadarida egyptiaca are one of the few bats in SA that echolocate within human hearing range, and I'll be using it. Obviously most of us know, other talks have greatly explained feeding buzzers, and the great thing about bats is they characteristically the frequency and the amplitude and duration change quite obviously. And I can now use that as a proxy of feeding behavior, because it doesn't matter if the bats are flying in, well, over and around the apple farms. That doesn't mean they're necessarily eating insect pests and helping farmers. So I realized I actually need to use feeding buzzers as a proxy for their ecosystem services. So as we know, if a predator hones in on a target organism, then the feeding buzz indicated there in red is what I'm looking for. I'm also going to skip over in terms of time, just the feeding buzzers methodology, but I use a very underestimated conservative approach. And this is just to show you in purple the total activity and number of bat passes on the farms is much higher to the proportion of time they're spending feeding. So foraging activity is much lower. So are the bats then just commuting or flying past or around, but they're not actually on the farms eating? And then I realized I don't know where my rhinos are. So I needed to go through all the calls again because the auto ID and filters were missing the rhinolophus bats. And this is normal because they're very soft, they have very high frequency calls, but they're also a conservation concern because they're cave dependent. I also need to verify the rest of my species list because the other photos show we should have bats there that I'm not picking up, and we have bats I am detecting that shouldn't be there. But luckily with the full spectrum calls, I could data mine and check again. And I realized there's a lot of background noise being saved as bat files. And this was from the pesticide sprayers. So I'm getting pesticide noise. There's a tractor, and they're extremely loud sprayers. And what is of concern, this is obviously, I'm doing more sampling, but when there's spraying happening at night, there's very, very low bat activity. Another big concern is apple farmers spray for 6 months of the year, and I was hoping to present this data, but they only gave me the spray records last week. But the point is just I now need to consider the number of spray nights and the time of spraying when looking at this data. And just a quick summary to show if we look at the farm closest to Drakensberg, although it's the smallest apple farm, it had highest diversity, some of the highest feeding activity, but also very low spray nights. And as I said, I haven't yet corrected for sampling nights, but there's a lot of factors going on. So what makes bats buzz on apple farms? I don't know yet. It's complicated, but I'm busy figuring it out. And there's been a lot of lessons along the way of hybrid methods, the importance of local reference calls, and establishing that baseline data. So a big thank you to the permitting bodies who do work with lovely farmers, and thank you.